Has anyone seen Ralph? Yeah, let's see if I can text him. Okay, Ralph's on his way. We'll start in a couple of minutes.
Hello.
Oh, yes. Did you say Jabba or? Tim's doing minutes. Just
Just-in-time slide generation.
of course, the left one's Mitico, isn't it? That's right.
How are you doing?
Hello, Joey. How are you doing?
Are we having some fun with HomeNet or what?
Hmm. Do you want to drive? Or?
Sure, yeah. Why don't you talk and I'll drive.
Okay.
I see what you,
And then there's the red button. I don't think we need the red button.
misunderstood drive. So, okay.
So we're hooked up by mine. Ted is still doing his slides, so we'll just plug him in when it's his turn. We've got the DNS push slides and the privacy ones. So.
Yeah, those are up. And then I have some slides for the
All right, the recommendations.
yeah, BCP stuff. That's what I was just doing with Stuart. So you've started the blue sheets.
Blue sheets are out. I think we're ready.
Okay, I think we're ready. And as I was saying to my co-chair, I apologize for being a couple of minutes late and finishing up my just-in-time slide preparation. Okay, so Dnssd working group. Here's your note well. Okay. Blue sheets are going around.
We have a volunteer for Jabba and minutes. So.
Oh, we do? Okay, great.
Thank you.
Great, thank you. Okay.
I want to mention these.
Yeah, the Etherpad, Tim will be taking notes on the Etherpad, right? So if you have been to the mic and see that your name has been transcribed incorrectly or any other edits, please feel free to contribute. Thanks. Here's all of our usual background information and the document statuses. Dnssd hybrid is, let's see, I went through this and I didn't keep my notes. We're going to mention Dnssd hybrid in a later slide. MDNS DNS interop is waiting for a Shepherd's cover sheet, and then it will go to the IESG. Dnssd push we'll talk about during today's session. I think that's it. Oh yeah, we'll also be talking about the privacy document as well. So we have a couple of major topics to talk about today. Was it the last meeting? That was the last meeting we talked about splitting them, right? Yeah, at the last meeting we came to the conclusion that the DNS push document really needed to be split into two parts, one of which is a more general session maintenance document to go through DNSOP, and one is a specifics for managing Dnssd push, which will go through this working group. So we want to make sure that we understand the split of that work and we get an update on where that work is. Ted Lemon has been working on a document that describes how unicast DNSSD, DNS update, and hybrid proxy approaches can all be integrated into a specific naming architecture for HomeNet. We want to review that architecture in this working group as well. Tom and I are going to talk briefly about hybrid proxy deployment and configuration in a larger scale network context. This is something we've also talked about with Stuart. The idea is that there are a number of components that all go together into a unicast DSSD deployment, and we think that there's room for a BCP document that explains all of those pieces in detail, although they all are documented various places. It seemed good to bring them all together in one place and then give some concrete examples of how you can use the organization DNS server, hybrid proxy servers, and the characteristics of the DNSSD clients themselves to stitch together clever deployments that accomplish certain requirements over and above simply giving a client a view of all of the DNSSD services across an entire organization. And then we're going to talk about the DNSSD privacy work. Here's the agenda.
Doesn't need to be bashed.
Nope, no bashing needed, huh? Okay. I mentioned the hybrid proxy draft. The plan is for Stuart to apply some final updates. We'll confirm that the working group agrees that the updates address the points raised at the last IETF meeting, and then that document will be ready to go to the IESG. Kerry.
Terry Lynn. I've been away for a while. Question to the chairs.
Welcome back.
Yes, thanks. Maybe it's a trend. Last time there was some discussion, last time I attended, there was some discussion of rechartering. Just wondering where that stands. Has there been any more discussion of it?
Yeah, I think we're at the point where the hybrid proxy is going to go through in the next month or two. The DNS push is now making it a way forward. So we've got some time at the end just to discuss next steps, and that can include what we might do to recharter. I think Terry, I don't know if Terry's in the room, whether he left. He was he's hiding behind somebody. Yeah, so we can have that discussion with the AD, but I think we want to be very clear that we're in a good position with the basic stuff we promised before we recharter, but we're probably quite close to that now. So I think.
So yeah, go ahead.
Sorry. So I think that the question here is obviously Stuart Cheshire is going to go and make these updates. Is there anyone that has any other comments to make beyond those that were raised at the last meeting? I think we were fairly clear in terms of what Stuart needed to do. I think he's fairly clear. But now would be a good time to mention it, Ted.
Ted Lemon. I didn't actually hear any feedback about whether the question of whether human readable names could be put into the main forward zone using TXT records, or whether we really had to have 3 zones. Did that get addressed?
No.
We should talk. Yeah. And is the MDNS hybrid presentation that you have on the list this, or? Okay.
There is no presentation. This is the slide, just to state where we are, and that we will have an update soon. Okay, so that's where we are with hybrid proxy. Next, we've got a short presentation from Tom on DNS push, which will hopefully clarify where we are in terms of things being split out a bit there. So, that's a good question. You've got to stand in the square. I don't think the clicker will work because it's off mine, unless Stuart happens to have his magic thing with him.
Oh, I see. Oh, wait a minute. Oh, here, yeah, it was stuck in the end here. I just found
Oh,
it.
sorry. All right, thanks, Stuart. Sorry. Well, I've no idea if that'll work, but let's have a look. Oh, there we go.
I think you just
Pardon?
close it.
Okay, so at the last IETF, Ray and Sarah and Allison and John kind of approached Stuart and I about some of the work we're doing with push. Looked a lot like what they needed for other things, and so they asked if we wanted to kind of get together and see if we could come out with something that would work for both of us. There's an initial draft that's out there, and we've had a good design meeting this time. We kind of defined that, well, you know, what a session is. We consider it to be a long-lived series of DNS queries. Either side can initiate it and get a response, and the messages should be arriving in the same order they were sent. So if you can, if that seems to apply in our case, we're using TCP over TLS, and there may be other transports that apply that as well, but we're not going to dictate what transports you use. It's just that those properties are what, you know, kind of match our use case.
If anyone has any questions, do come up at any time. Don't need to wait to the end.
So we're collaborating with them on this. This allows us, instead of having per packet signaling messages like the EDNS 0 keep alive options, we can do it for the whole session, set it up, and then we don't have to do the extra options in every packet. So that work is progressing, and we should have a new draft out soon based on the discussions that we had. There's a terminate message already in there, and we can use that directly. We may end up with our own, keep our own formats for subscribe, unsubscribe, or reconfirm, or we may be able to incorporate those into the session signaling as well. That's something Stuart and I are going to look at. Let's see. One advantage is that session signaling is going to have its own opcode and can define its own packet types. And if we piggyback on that, then that reduces the number of opcodes that we use. But that's just bits on the wire, and we're more concerned about whether it fits in right. There's with the new opcode, there's the ability to define entirely new packet format that's optimal for the TLVs that we would like in session signaling. That's something that the session signaling group we're trying to figure out what the optimal case there is, and the next draft will have that worked out. So we hope to have a new draft out soon of the session signaling, and then we'll update the push draft to reflect all those changes. The general architecture of push isn't changing. This is just a new way to encode the messages. And so I'm sorry if you've done a implementation, but I don't think it's going to really change much for you. So, but there will be a different way to encode these messages on the wire. So questions, send them to Stuart and I.
Okay, do we have any questions on the approach here? So yeah, if you look at the current DNS push draft, I think version 8, that, as Tom says, is going to be significantly reworked once the signaling stuff stabilizes. I think there's still some discussion happening there. Stuart has a comment.
Stuart Cheshire. Yeah, just to clarify, we're not expecting the semantics to change. The syntax will be modified to comply with the new session signaling draft, but the idea of what it's trying to achieve is not going to change.
When will the new draft come out? I don't want to get up.
The question was, when will the new draft come out? We had a long meeting to discuss session signaling here at the IETF. My plan is to update that document on my flight back on Saturday. And then if my co-authors approve it, we'll have the session signaling draft done and give that a couple of weeks for people to look at it. And if people are comfortable with that direction, we'll then update the push draft to adopt the new syntax of the session signaling mechanism.
So I should not see the call for adoption and Dnssd until this new version comes out?
Yes, and that's why I want to get it done on the flight back, because I do want us to have the discussion fairly quickly, but not before Sunday.
So sorry, the question there was about adoption, so that won't happen just yet. Right?
Yeah, sorry, just flag up. Stuart and I are actually going to talk about maybe get something out sooner than that. So, because I've got some cycles between now and the end of the week. So,
Wow. Okay.
It's high priority for us anyway, either way.
Right.
Good. Thank you.
Okay, so we have forward movement, and I think we have agreement on how things are being split. So that's what we were happy to make sure that we had today. So that's good news. So where are we?
Just send us the slides.
So the next bit would be Ted's. You just sent the slides.
Yeah, I have them. I guess
Okay, do you want to move over to yours?
Yeah.
See how that goes.
Oh, not very well.
Ooh.
By the way, I got the title wrong. I apologize.
That's okay. What's the magic? Make it full screen thing, or maybe it's just that.
Let me just see if I've got the email.
Okay, I got it.
Okay. So you'll need the dongle as well.
Oh, right. Oops. That's a big one. This side.
It's there.
That's for you.
Oh, party on. This is actually a somewhat mistitled slide. The intended use case for this right now, the motivating use case, is HomeNet. So that's why the slide is or was formerly titled like that back when it was on the screen in the good old days.
It's a hardware problem.
Yeah,
I can see it. You mirroring properly?
There.
Yes? No? Yes.
This time-
Excellent. All right. So
Step back for a little bit.
yeah. All right. So the motivating use case for this is that we want to be able to use something like Dnssd hybrid on a HomeNet, but Dnssd hybrid presumes essentially a managed network with an understandable network topology And that's really not characteristic of home nets. So people are going to plug, I mean, anybody who's been to the house of somebody who is not a network expert, who has a home net or a home network with more than one router, knows that they just plug them in together randomly. And that has to work, and it has to make sense to the end user when they see the results of that random connecting of the network. So in order to make that work, I shouldn't say we. Essentially, I've been doing all of this work, and I encourage people to participate and throw tomatoes and so forth. But anyway, I have been the solution that I thought made the most sense was to have the home net essentially have a local DNS zone that has all of the names in it. At least that's what it should look like to the end user. That's a little bit different than the Dnssd hybrid model. The Dnssd hybrid model has what looks like a zone for every link. Actually, 3 zones for every link. We need to talk about that. It's a really neat solution. It basically works by triggering, if you do a DNS query, that triggers MDNS queries which answer the questions. And if you're using DNS push, then you get better results. It's a very nice system, which for the most part, I think we should also use on home nets. It also does support, I think, caching, but doesn't require it. The idea on home nets is that I think on a home net, in order to make the network make sense, we actually need to build a cache that has the information we've learned from the network. We need to be a little bit more proactive in learning information about the network, which means that we'll probably sit there and listen for, when an MDNS device is powered on, it announces that it exists. That's the last time you hear about it unless you issue a query. So we want to track that. We want to track what happens when people make queries and so forth. We don't want to reveal the topology. In order to not reveal the topology, the reason why Dnssd hybrid reveals the topology is because it eliminates the conflict problem, the naming conflict problem. If you have 2 devices on 2 different links with the same name, they don't have the same name because there's an additional name interposed that identifies the link. And so you just have printer A on link A and printer A on link B, and there's no naming conflict. It's a little confusing maybe, but there's no naming conflict, so that's a good thing. But link A and link B aren't going to make any sense to an end user. They don't know what those links are in a home net. Like at a college, the link A might have a name that the administrator put in it that actually makes real sense. That's not going to be the case here. So to handle the duplicate problem, I've thought about this a lot, and this is very much a work in progress, and I'm open to alternative suggestions. The various things that I've considered have been just essentially taking the duplicates from the MDNS database or from the MDNS queries and adding a little identifier that's like a number that represents the link. My current feeling about this is that the best thing to do is actually cross-defend once. So suppose some device comes up on link A and says, "Hi, I'm printer 1," and then some device comes up on link B and says, "Hi, I'm printer 1." The home net will defend that name against the second printer. And one of 2 things will happen. Either, assuming no attackers, which it's a home net, I mean, whatever. So either both printers will change their name or only one will. In the case where only one does, it was actually 2 different devices. In the case where they both do, it's the same device. This is my theory. So that seemed the nice thing about this is, as compared to adding on some names in the DNS view of the MDNS namespace, is that now the names are consistent when you see them in the user interface. So if you've got a user interface on your Apple that's telling you how to access file sharing or the web server on your Apple computer or something like that, the name that you see will actually work both for MDNS lookups and for home net lookups, at least in theory. So anyway, I just thought of a problem with that.
Don't you hate when that happens?
Yeah, which is that .local and .homenet are not the same string, but life is full of tragedies. Anyway, as you can see, this is very much a work in progress. It needs work. But the idea is that we keep a real DNS zone with forward and reverse lookup information, and that can be securely updated using DNS updates, or if the service doesn't support doing secure updates, which have to be signed with SIG0, then it can just do the update on the local wire, and we basically treat it as just as trustworthy as an MDNS advertisement, which is to say, what are you going to do? But we give priority to names in the DNS zone. So if we have a device that's publishing its name in the DNS, and then some other device comes along and publishes a name using MDNS, then the HomeNet will defend the name, so that the second device that came along, because in this case we know they're different devices because one of them supports DNS updates and one of them doesn't. So in that case, the HomeNet will defend that name using MDNS, and presumably the second device will get a different name and everything will look good. If you want to do queries, if you want to do service discovery on the HomeNet, you use DNS. And use Dnssd, not MDNS. So HomeNet router is not going to answer if you ask for something in .local. As I said, HomeNet defends names, listens for queries. So every HomeNet router will have something listening on port 53 for both TCP and UDP. Whether it has a resolver in it is an open question, but every HomeNet has to have at least one thing that can do name resolution. And other HomeNet routers can, and this can be agreed on using HNCP, and if a HomeNet router doesn't support that, it'll just forward the queries to that router or to that device. So if you do a DNS query, you're going to get answers both out of the DNS zone and out of MDNS. I think that the way to make this work is to have a per-link cache of MDNS data, which would have actually 3 sort of pseudo zones in it. That question occurred to me kind of out of order. I made these slides up about 2 minutes ago. So a couple open questions. There are open issues with the name claiming stuff, and actually I'm no longer convinced that it works. But that's one question to answer. Another question is, do we maintain a DNS zone that has everything in it and has a serial number? When I originally thought this through, the design was that it would in fact have a serial number and would contain all of the MDNS data. I think that works best, but it's a little harder to implement. So there's a trade-off to be made there. The reason why it works best is because now if you do a DNS update, the data from MDNS is there and can be seen by the update query. So updates have predicates, and if you put in a predicate, you'd like it if a host tries to create something, but only if something else is true, we'd like that predicate to actually work. So that's kind of the motivation for that bullet item. I don't know how important that is. This really needs to be fleshed out. So this draft is in a highly non-complete state in my head. It's a work in progress. I need to do a lot more thinking. I could really use some help. Tomatoes are solicited, but do bear in mind that this is for HomeNets, not for schools or anything like that. There isn't anybody managing it, so it can't really be treated the same as if it were sort of the main motivating use case for Dnssd.
Tom Pusateri, can we go back to the problem statement a minute? You're objecting to ugly host names? Is that what you're?
No.
No. Okay.
No, I'm objecting to revealing network topology in the host name.
Okay.
Yeah. And the reason I'm objecting to that is not because it's inherently bad. It's not. It actually makes sense if you have a managed network. But I don't think it makes sense if you have a HomeNet, because the HomeNet's topology is essentially random. And the end user is going to have no idea which link is link 1. They're not even necessarily going to know what a link is.
Right. And why do they care? Like if there's some string at the end of this name that they should never see, because they should see a description of the service instead of the host name anyway.
That's not entirely how Dnssd works. That's certainly one model for how Dnssd works, but that's not the whole picture. Like if you're using, you know, I see many Apple logos here. Any one of those laptops, if it's doing AFP, is that right? Apple file sharing. In the user interface, when you enable file sharing, it says this laptop can be reached on this address, and that's true for SSH and all those things. That address has to make sense. It's not good enough to say some addresses make sense, but other addresses will be gibberish. They all have to make sense. And people are used to domain names. They know what they look like. They kind of have, they don't necessarily understand the structure of domain names, but they've seen enough of them that if you present them something weird, it's gonna be a problem, I think. It's a usability issue. So I don't know. This is definitely a matter of taste. I may be completely wrong about it, and I'm certainly proposing to do a fair amount of work to avoid it. So it's a good comment.
Ralph Drum's chair hat off. I think one of the issues here is there may not be any one right answer. That is to say, what the word reveals means to you is different from what it might mean. What the word reveals means to you may not mean the same as what reveals means to a casual user. Mm-hmm. That is to say, a lot of the existing Apple interface anyway hides the entire DNS structure. So
yep.
So you know what I'm talking about.
Yep.
So all you see is the host name. You don't see all of the other stuff.
Right.
For those examples, perhaps the fact that the hybrid proxy solution injects this extra revelation of the topology is irrelevant. But I think we need to talk about it. I'm not.
Yeah, I mean,
you and I could drink a lot of beer arguing about that,
yeah,
discussing this vociferously. But I think that's a question we have to answer.
Yeah,
I mean, I don't know who has the answer.
One answer to this is let's do plan A, which is reveal the topology, and then we can add later a way of unrevealing the topology. My only and I don't see any particular downside to that, and maybe it's not worth. Okay. So there's someone behind you who just went like this when I said that. So maybe he has a stronger.
Yeah, but he
opinion
doesn't.
about this.
He cares about the full domain names that are revealed too. I'm not sure that everybody does. That's the underlying question.
The thing that I think is really important to keep in mind is that in the IETF we have this idea that end users are completely stupid.
No, I don't think that. I think, but they have a different idea of what they're looking for.
Every user has a different idea of what they're looking for, and what I want to do is make it be the case that what we present is as understandable and as simple as possible without being so simple that it actually becomes more complex, which is often a problem.
It actually might be worthwhile to run some experiments, to actually do some demos to see here's a hybrid proxy deployment, mm-hmm. and here's what happens when I connect my iOS device onto the first SSID on this little home network deployment with these ugly names, and see where I just get the host names, and the service instance names, mm-hmm. and where I get actually the full ugly names, and see what's tolerable and what's not.
Yeah, I mean, the other problem is I just really don't know what we would put in those names.
Well, I've spent a little time reading the HNCP document recently. Mm-hmm. Some of you may be aware of that.
Not that we're bitter.
Yeah, no, I'm not bitter, but I have been spending a lot of time trying to read it.
Yeah.
And there is something in there about having that HNCP routers are required to assign a name of some sort to every link.
Yes.
So if that's already happening, then that's...
Yes, but what does that name look like?
And we're coming full circle because I claim I don't care. Even I don't care.
Well,
certainly,
so for example,
anybody who just
UUID?
sees the list of service instances doesn't care.
It could be a UUID, it could be an interface name.
Yeah, right. So,
and by the way,
they're never going to show up. That's the whole point.
Yes, they will.
Okay.
So for example, suppose you have printer A on link 1.
We're not going to settle that argument about whether the names show up or not by arguing about it. Well, because you folks are wrong and you're not listening to me. we do need to run some experiments to say,
Yeah,
hey,
so
let's do this with some ugly names on some links and pop up the interfaces and see what they look like.
yeah, I mean, forgive me, but what you just said slightly trivializes the conversation, though, because it's pretty clear that the names will show up, because if you've got a printer on link A and a printer with the same name on link B,
Right.
you're going to see the name. There's no way to avoid that. That's part of the design.
That's okay.
Now, it may be that never happens, in which case we're fine.
Okay, I happen to have sent an email on this precise subject to the HomeNet list within the last hour without my chair hat on. These, Ted said, these names do appear. Not every device that you access via Bonjour with .local is accessed via a device class specific control panel which hides that .local name from you. Yeah, I have 2 devices on my home. One of them is a NAS, which is primarily accessed as NAS.local, and the management of that is done via a web browser. I want to be able to bookmark that. I don't want that bookmark to change depending on which particular segment of my network that NAS is currently plugged into. So, I think not only should we not get hung up on just the human readability aspect of this, but it's also the subsequent usability of these names.
Yep.
As far as I'm concerned, the namespace should be flat and it should be persistent, except in the event of there being a collision.
Yep.
Yeah, because I don't want to have to go and re-edit all of my bookmarks in my browser, which is not a particularly smart, Bonjour style device.
So what we're getting,
By the
here
way,
is-
sorry.
so what we're getting here is some indications of the requirements we're actually trying to meet here.
Right.
And it might be worth capturing those as
Yeah.
while everything else is in your head to
Yeah.
start off with.
Yeah, that's a very good point.
Stuart Cheshire, actually, I have a quick question for you, Ray. Which browser are you using?
The one supplied by my ISP. Oh, I can't actually remember them all.
Internet Explorer 6.
So that sounds like it's not Chrome or Firefox or Safari or Internet Explorer. It's some other web browser.
Oh, sorry, so which browser? Yeah. Oh, sorry, Chrome. I thought you said which browser.
Okay, so what I hear there is a call for the Chrome web browser to have a Bonjour list of services so you don't have to bookmark them. Is that correct? Say yes.
I am aware that such a thing has existed at times, or in fact is enableable. Yes, I'm aware of that. But not all browsers do.
Yes. A little private joke. I'm painfully aware that Safari is the only browser that has a pull-down menu of Bonjour services, and it's a thorn in my side. So moving on, listening to all the people who came to the microphone, I found myself sort of 3/4 agreeing with everybody. It's like a big Venn diagram. One point that is maybe my failing for not communicating it more clearly is that the hybrid proxy document is intended as a building block for a larger solution. It is not by itself the total answer. And that's in my head, but it's not written down anywhere. Ralph has already suggested that we need some kind of BCP or deployment advice or some kind of guidance for how you build a system using these building blocks. And that's a gap that we have right now. I actually agree with you that the final solution that we put together should hide these link names. Part of that is a question of UI that we don't design in the IETF. I agree with what Ralph said, that part of this process is we should take a look at the current UI that exists in various bits of software and see how it handles this and displays it, because the display is not uniform and consistent. For instance, Safari will just display the instance name as long as it's unique. But if it finds NAS device on 2 different subnets, then or 2 different subdomains, it will put the subdomain name in parentheses after the device. So you'll have NAS device, or you'll have NAS device brackets Ethernet, NAS device brackets Wi-Fi. I'm not advocating that, because that's full of problems, because if you call your device NAS device brackets Wi-Fi, then but the point is that is something the Safari engineers came up with, and other tools. So the UI is not consistent. To make things even worse, once we roll out this hybrid proxy stuff, and it becomes widespread, those application developers may well go and update their UIs in response to that. So that's a moving target.
Yep.
So it is kind of a complicated situation right now. So that was all sort of to acknowledge the various points that have been made, because there's truth in all of them. I'd be happy to work with you on the document you're writing, and if anybody else, we can make a design team, because I think there is a need to go beyond what we currently have and put something together that's usable. And we want that to work, because we want to have it at Apple when our new headquarters building opens up. We want all this stuff deployed and working.
So let me just say that having listened to you say that, I realized that I actually made the complete wrong slide deck. Because the sales pitch that I really want to give here is the sales pitch for we need to replace MDNS with something that works on larger networks. And which I don't think is controversial. Maybe I'm wrong. The reason being, MDNS works really well on a single wire. I mean, it's great. Everything works. But what we really ought to have is DNS updates, because DNS updates are not link local. And so what we really want is to have all of these printers that you buy send a DNS update with some security payload that allows the printer, once the name has been established, to defend it so that that name never changes again. Because that way, the use case that Ray's talking about works, and it doesn't matter what the UI is. And that's really what I care about. So the whole point of this is to create a context in which there is an incentive for printer manufacturers to do something other, and for everything, NAS manufacturers, whatever, to do something other than MDNS. Because you have DNS update in RFC 6763.
I foresee several beers in our future, Ted.
What's that?
I said I foresee several beers.
Yes, well,
in our future.
we've cried in beers in your case and sodas in my case over many a time in the past on this, so it's not news. But the point is that it would be nice if we had it. Right now, we're not even asking people to do something differently, and it would be nice if we were.
Okay, thanks. I'll make one quick final comment to Ray's point. I completely agree with what you're asking for. I just don't know how we do it in the general case. And what I'm talking about is, if my NAS is on Wi-Fi and I decide to run a gigabit Ethernet cable to it because it's faster, I completely agree with you. I would like the name to not change. I would like the bookmarks to not change. But how far do we take that? If I take the NAS to my office and plug it in there, should my bookmark at home still work? Because that implies global naming. And so when you say you want to move it without the name changing, the question is, how far can you move it before the name has to change? Okay.
So I actually deleted from the last slide a question. Why did Kerry put his head in his hands at the end of my talk about this in HomeNet? I felt that didn't really belong on the slide, but proceed.
Carrie Lynn, jet lag, probably. But just as a general comment, I feel like we must have missed something during the requirements gathering phase of this exercise. So not expecting a response or anything else, but it would have been nice if we had this, sort of earlier in the process. I want to make a quick point to something you said in passing, which was we need to get printer manufacturers to do something other than MDNS. There's like millions upon millions of printers already in the field that do this.
Yeah. It's got to
We're
work.
not going to strand all them, right?
It's got to work.
Yeah.
Yeah.
So
absolutely.
But my real question is, are you assuming that the capability to change an instance name doesn't exist, or that the users won't know how to use that?
The capability to change an instance name.
The instance name of a device.
Well, no, I mean, devices have user interfaces for typing in names frequently. I mean, not necessarily always.
So then if the two names, show up in the same namespace,
well, so there isn't
the user just disambiguate those two names so that never happens again?
So in order for that to, so there's two ways that can work. One is that the name is dependable. That is to say, it's not going to change ever again, assuming that you don't get rid of that printer or whatever. But as long as that printer still lives on your network, it's always going to have the same name. If you can make that assumption, then the UI can just put a different name on the printer. There are a couple issues with that. One is, if you do that in the UI on one laptop and you don't do it in the UI on another, now you've got two UIs showing a different name for the same object. You don't want that. So what you really want is a way to have a UI. So when you go to your UI in Chrome, you can click on the thing, or in Safari or whatever, you can click on the object and you get a little cursor in a text field, and you can edit the text field. And then when you're done editing the text field, some message goes out on the wire, and as a result of that, the name of that object is permanently changed. And ideally, you want that change request to go all the way to the object, right? So,
So
but
it sounds
that's
like a new API that you're suggesting.
well, it's not just. I mean, we're not going to do the API.
Well,
But is there a way for us to do that with existing MDNS? I think the answer is no, right?
there's generally a way to do it with an existing printer. You just basically, you know.
Well,
open
right,
up
but we
this-
can't, every printer has its own management API or its own management
Which you
UI.
get to by finding the printer and then going to port 80 at that address.
Yeah, that's not, I mean, from a usability perspective, that's better than nothing at all, but it's not a lot better than
All
nothing
right,
at
so
all.
then in answer to my question, you're assuming that users are too stupid to use it, basically.
I'm not assuming the user is too stupid to use it. I'm assuming the user is not going to be able to figure out how to get to it. Or it's likely that the user is going to be able to figure out how to get to it.
So one more comment from Stuart, then we need to move on.
All right, I'll try to make this quick. It sounds like what you're proposing, Ted, is something like an SNMP set operation for some standardized mechanism for set the name of a device. And I'm actually not saying that to advocate it. I'm saying that to kind of point out that, you know, maybe it's never going to
It's a hard problem.
I would love to see some standardized network protocol for set name of device. I just don't know how we'd get anybody to adopt it.
Yeah.
The reality is what Kerry says, that almost all devices have some web UI with something buried in the settings where you put in the name. It is really frustrating that it's hard to find. It's very inconsistent. I recently bought a new house and I've been buying amplifiers for the stuff, and it's actually been really gratifying to me that almost every device I've bought has a Bonjour advertised web UI on it. In fact, it's really surprising. I wasn't searching for that. That wasn't my litmus test for whether I buy a product. The latest ones I got was in 2 inverters for the solar panels on the roof. There is no way to change the name, but that's okay, because one of them is called SMA 19990004546, and the other one is called SMA 19900005082. So no need to change.
Those are very
names.
easy to tell apart at a glance. This is.
So I'm agreeing with you.
Yeah.
We need. I would love the products to be better. I don't know how we get the products to be better, except that if there's more people using them and complaining that they're hard to use, then the vendors will have an incentive to fix them.
And if there's a way that the vendors can fix them that is standardized, maybe they'll use that instead of inventing some special snowflake way of doing it. Maybe.
Okay. Final comment coming up.
Okay, so Wolfgang Riedel. Maybe I missed something, but your IP addresses have to come from somewhere. So this is typically your DHCP server. Within your DHCP server, you have a way to also assign host names. So they don't have to be the ugly way. You can really assign nice DNS names via your DHCP server, and typically they get registered via dynamic updates to your DNS system anyways. And another point is, like, think about the use case: your NAS is dual homed and your Mac is dual homed. So I want to have the link name in my name, because it's like, I don't want to run my backup from my Mac over the Wi-Fi if I have a parallel path, like going over wired, because it's maybe 5 times the difference in timing, which takes it doing this backup over the Wi-Fi versus wired. So I think there's some use case in having the link in the name somewhere. So just.
Yeah, that actually is a good use case for having a link in the name. DHCP is not really a thing on home nets. Maybe if you're using IPv4, but we're not expecting people to do that. So, yeah.
I know we're short on time, but I'll,
That was a little bit political. Yeah, I try to be subtle.
I'll be very quick, so I know we're short on time, but just I hear this frequently that, oh, DHCP will give you a host name. And I hear this a lot, and I've never seen it actually used
It doesn't actually work.
Because it doesn't actually work. Because I walk into your house with an iPad. How does the DHCP server know what the name of my iPad is, right? It can give it a random address from the pool, but it can't tell it what its name is.
And would you like it if your iPad trusted your DHCP server, some random DHCP server to give it a name?
Okay, so I think what we're hearing here is, well, thanks for doing the work, Ted. It's much appreciated. Clearly, Ted needs help. There's a suggestion of having a design team, whether formal or informal. I think that would be a good thing to do with people like Ted, Stuart, Ray, if they're willing to do that, and any other volunteers want to come forward. Does seem to be the kind of flat home net problem that we're trying to solve here, but there's also the interweaving of DNS update and hybrid proxy in a campus type environment as well. So there's two threads there. Final question, I don't know if it's for Stuart or who it's for, but is Marcus Stenberg in the room? No. Well, he's got okay, maybe you can answer this, Ray. There is a draft Marcus wrote about hybrid proxy in HomeNet. Are you suggesting that's no longer the way, or? Okay, all right, we'll take that offline, never mind. Okay, so I think the next item is Ralph to lead a little discussion on.
And I know, Tom, you had.
Sorry, go on.
Did you have some slides or anything ready to? You were going to talk about your implement. Oh, okay. Okay.
Did you have slides?
I have slides.
Okay.
I'll walk through what I have to say. What we were interested in is your work on hybrid proxy implementation. But let me walk through my slides and then chime in. So I'll take this back.
So what we're talking to here is what Stuart alluded to, with the fact that hybrid proxy is a tool that we can use in different ways. And the question is, what sort of guidance or best practice can we recommend for doing that, particularly in a campus environment?
And I have, let's see. Okay. So I have nothing like a BCP document, nothing like laying out all the possibilities. All I want to do today is run through some of the components that make up the building blocks of Unicast Dnssd, as Stuart was alluding to, and give one small example of how those can be put together in a particular way for stitching the various zones together to accomplish a particular requirement. The idea here is, as Stuart was saying, to get to a unicast Dnssd deployment while still accommodating multicast DNS devices, and start broadening the way we think about these pieces as building blocks and being able to be put together in lots of clever ways. As always, since this is a naming problem, there are lots of opportunities for doing clever things with names and levels of indirection inside the various components that we haven't really even started to begin exploring yet. Okay. So we all know this stuff. I just want to make sure everybody's on the same page. Dnssd is independent of the DNS transport, right? You send the same queries over multicast DNS as you do over unicast DNS, and they get evaluated the same way. You get the same responses back. It's just a question of the transport, whether it's multicast DNS or unicast DNS. Unicast Dnssd is a good thing. It avoids the overhead of multicast DNS. I may have relayed this anecdote before. A friend of mine captured a packet trace of traffic at a Cisco Live, where the deployment tends to be a very large bridged single link in which there may be as many as 10 or 20,000 people. And you know how we are. We probably have 3 or 4 of these things that we're all carrying around, communicating over MDNS. The traffic, the multicast DNS traffic on that packet capture was something like 40% of the packets over the period of time that I looked at it. So DNSSD avoids all that overhead. And DNSSD can avoid the overhead even if you're using multicast DNS for legacy devices, because you don't have to forward the multicast DNS traffic from the legacy devices across the entire multi-link network. You can you can isolate it to a single link and then use unicast DNS in clever ways to communicate across, to do DNS service discovery across remote links. So some considerations. There's this consideration of scaling responses to service discovery. It's great if we can have a way of merging together multicast DNS, unicast DNS, SD into a single sort of search domain. But if I pull down the menu and ask for all the printer services at Cisco, I'm going to get a list that's way too long and not very relevant to what I want to do. So I want to be able to filter that to get just the printers that I might be interested in. One way to do that filtering is to modify the responses that come back from Dnssd service queries based on location. So is there a clever way I can take the Dnssd infrastructure and structure it in such a way that I get back just the responses from devices that are physically in my vicinity? And as I said, we've got to accommodate legacy devices. This was the conversation we had at the end of the previous presentation. For the time being, we have to accommodate multicast DNS devices. There's no way around it. We don't have a way of going to entirely unicast Dnssd, but that would be a great goal. Excuse me. So what are the tools involved here? What are the building blocks that we can put together in to get a merged unicast DNSSD, multicast DNSSD? Well, first of all, there are these Dnssd client configuration resource records. There are actually several of them. I've just put one example up here as an example. So, these configuration RRs come from a couple of different places. So the idea here is the client device gets its domain name from DHCP. So for example, example.com. It prepends lb._dnssd._udp, sends that out as a unicast DNS query. There's a second kind of query that's made by taking the subnet that the device is attached to. So the device takes its address, its IP address, applies the subnet mask, and gets a subnet number, puts it into in.adder.arpa format, and issues that request. And then finally, it'll issue an LB request on .local over MDNS. Now, these responses come back, and I'll show you how these responses come back and get merged together in a second here with an example. But the responses all come back and get merged into a list of, it's essentially a search list for doing DNSSD queries. So the next set of tools is the hybrid proxy servers themselves. I do have a pointer. The hybrid proxy servers themselves. And then there's the organization DNSSD server, or DNS server, which we're going to use to stitch all this stuff together. So the organization DNS server has the unicast DNSSD client configuration RRs, these things. It has the delegations from the central zone for the organization to the hybrid proxy servers, and it's got these funny subnet entries. Okay. So how do we stitch all these things together in this particular example? In this particular example, what I want to do is show how we can do use hybrid proxy servers to generate location-dependent search lists so that a device will only get services that are of interest based on its location in a building. We got a building with 3 floors, floor 1, 2, and 3. The device is going to be on one of those floors, and it's going to get a DNSSD unicast search list that depends on which floor it's on. And therefore, it will only search part of all of the available services and just look at the adjacent floors. So if it's on floor 1, it's just going to look at floor 1 and floor 2. So we deploy hybrid proxies on all 3 floors. We put the delegations of the organization servers, and we add these entries for each link. Okay? So we've got the browsing domain link for subnet 1, which I'm assuming is on floor 1, and it gives back 2 PTR records, floor 1 and floor 2. That means that any device that's on this link, which is on floor 1, will get back this list of 2 search domains. Did I get that not quite right?
No, you got that perfectly right. I wanted to add a comment.
Oh, okay.
Because this, is something that comes up repeatedly. I want to make sure everybody realizes that what Ralph is describing here is not a proposal for what we might do in the future. This is the software that you all have on your Macs and iPhones today. And if you hit Command P and the terminal room printer shows up, or you press the AirPrint button on your phone, this is what it's doing.
Right, that's exactly right. And this example, although I didn't actually bring the config files with me from the demo I have set up at home, is exactly the demo I have set up at home on 4 Raspberry Pis and my iOS device and a Wi-Fi printer. And it does, this all works today. Uh-oh.
Is that you?
Wow.
Okay, so this is what happens for a device in subnet 192.168.1.0, which we assume is assigned to the first floor. A device in subnet 192.168.2.0 on the second floor gets all 3 search domains, and then the device on the third floor just gets floor 2 and floor 3. Okay, so when one of these devices now does a pull down to do service discovery, it will either look at the services on the hybrid proxies in floor 1 and floor 2. If it's on floor 2, it'll look at the hybrid proxies on floor 1, 2, and 3 and get all of the resources back. If it's on floor 3, it'll just look at 2 and 3. So the unicast Dnssd client on floor 1 resolves its browser RR. It sends out these queries. The results are merged, and the leftmost labels, the instance names, are displayed. And so you'll actually get the little pull-down menu that has just the printers on the local link, on the .local link, and on floor 1 and floor 2. That's pretty much it. That's trying to kick off the discussion, trying to give you an idea of where Stuart and perhaps Tom and I are going to start in writing a BCP document that lays this out in more detail, that gives some gives more examples about how you can stitch these things together in more clever ways.
Yeah, so there are many pieces to this puzzle. This is probably from the configuration, from the administrator of the enterprise's point of view, and what tools they would have to actually put these records in place, of course, is another question altogether.
Yeah, so that's an excellent question about what tools the administrator has to put these things in place. Now, let me try 2 different scenarios. The first scenario is if you're considering an enterprise scale deployment where you actually have a real administrator, there's still a lot of opportunity for support tools here. So if you were to buy all of your gear from some major router vendor, they might give you some support software that goes along with this that takes a very high-level description of the topology of your building and translates it into all the detailed little DNS RRs that have to go into the enterprise server, that reaches out, touches the routers to configure the hybrid proxy servers, and make sure all of these pieces fit together in the way you expect, right? It's not too much of a stretch to say, gee, I've got this high-level description of what this thing looks like, and I'll just go push all of these crazy RRs out and push out all of the configuration pieces. Now, if you're in the home network, you wouldn't probably use this strategy for trying to restrict the search areas, because you don't have an administrator and you don't know that the first router is the one that's downstairs in the basement next to the DMARC where your internet comes in from some major ISP. And the other router you have is up in the far bedroom corner on the second floor, because the Wi-Fi from the first one doesn't quite get around the corner of the wall in the basement, and you needed a second one upstairs. So in that case, instead of individual browsing lists for each individual subnet, you just use a system-wide browse list for all of the devices in your network. Everybody gets the same list of all of the hybrid proxies in the network, and I can imagine using HNCP, for example, to gather up the names of all of those things and use them to inject into the DNS server, the DNS resolver that's in your home network.
So part of that is to avoid being swamped with responses, which would not happen in a home net anyway,
yeah,
of course.
Right, yeah.
So let's have another, we've got a bit of time for about 5 minutes of comments before we take this to the list. Hopefully this has given the room the sort of feel for the type of things we're trying to do here. As I think Stuart mentioned earlier, there are other issues like what the UI looks like, and Ted hinted to that with what he'd like to do with being able to name devices. So there are many pieces to this, many of which aren't within our remit to actually deal with. So let's take some questions from the mics now. There's 2 people up there. We've got time for about 5 minutes.
Yeah.
Oh, sorry.
So go ahead, you were at the line, but we'll remember John.
Yeah, Björn Paulsson, Nordnedutveckling. I have one thing, a concern when you're talking about delegation to the proxy server instead of update privilege. Delegation gives you permission to do anything on that subdomain, including things that doesn't really make sense in what we're talking about here, like MX post or domain validation for that subdomain, of course, but still domain validation. And that made me a little bit thinking like, okay, so the weakest point in the domain name suddenly become whatever that proxy service laying, like maybe floor 1 is a reception of a bank. Okay, that service now basically in the name of that domain name, and the central domain name is well protected in safe place, but not that machine. So why is the draft suggesting delegation and not just updates?
So I'm not going to answer that right now because A, I don't know how to, and B, I think this is exactly the kind of consideration we want to put into the document in the long run, rather than trying to worry about the specific solutions here. But that's exactly the kind of thing we need to walk through.
So please make that point to the list so we make sure that it's captured. Tom? And sorry, there's Jabber's John Clenson, was it?
Yeah.
So Tom first and then John.
So I wrote a draft that's expired now that kind of lists out all the parameters that you would want to configure for a hybrid proxy, kind of a minimal set anyway. Those can be configured from either direction. You can configure it at the delegating server to get in the hybrid proxy, can figure out what it needs to know from the delegating server. Or you can have the delegating server, or you can have the hybrid proxy update the delegating server. And so they're in a kind of an auto configuration mode. Okay. And so I think we wanted to make the distinction between the 2 ways you can do it. As far as the previous question about why are you talking about delegation servers, well, each of the subnets on a hybrid proxy are truly delegated and have their own subdomain names. So that's we have to use delegation in this case.
Okay, so so how do we bring John in? Do we?
I think we hit the red button for John.
I'm going to get to hit the red button. Woo-hoo.
The magical red button. Hi, very briefly. First of all, there are I inserted a couple of snarky comments in the Jabber log that you might want to take a look at some stage, but are not worth spending time on today. More important, just as an observation about how complicated the world gets, I've been working with some architects of the traditional building variety on what turns out to be an aspect of some of the problem you've been talking about, Ralph. And just want to mention that some of the assumptions you've made in your presentation assume either that everything is wired, or that when we design buildings and their interiors, we are going to insist upon new kinds of carpeting consisting of wire mesh, which runs edge to edge across rooms and is thoroughly grounded sufficiently to prevent radio waves from moving between floors. And I can't tell you that's going to happen. I don't think it's going to happen. But it's another issue which increases the complexity of this problem in the real world. Yeah. And I just thought it was worth.
And I think, sorry, John, go on. Yeah, and I think from in my experience of managing the campus environment, when you do a campus-wide deployment of wireless, for example, you have a number of controllers, and the access points they control can be anywhere. And you have things like VLAN pooling. That means you can have 2 devices in the same room. So we need to think about all these things. I think it's a very good point, and please do take that forward on the list.
Yeah, that was the comment, was need to think about it. Thanks.
Yeah.
Thanks, John. And yes, I've been talking to the
If Daniel
wireless.
can come up while we just finish off here.
Sure. I've been talking to the wireless folks and the wireless controller folks at Cisco to understand that world better than I currently do and to see how it works in this context. Thanks.
Okay. Have you got Daniel's slides on yours?
I don't, I can't.
Might be quicker now you're all plugged in.
Just,
Take a question while we switch over.
Just one thought about it's like, isn't this a similar problem like we have with this, say, 911 calls location for emergency calls with IP telephony? So where you also have to submit some kind of a location where you are? I'm just asking, it's like, isn't it more or less the same goal we have, or problem we have to address and solve?
I don't have an
I
answer
just see
to
this
that one.
being a requirement for IP telephony, so where you have to submit the location for emergency call. So
I agree the similarities, and I think likewise, we don't currently have any solutions because I'm not aware of any technology in my phone that knows what floor of the building I'm on right now. GPS only works at all outdoors, and even then, not to a sufficient accuracy to tell you within a meter where you are reliably. So, yeah, it's an open problem.
Okay, can we have Daniel or Christian up? Thank you. So you've got 15 minutes for the presentation and chat, so off you go.
So, hello, my name is Daniel Kaiser. I'm a PhD student at the University of Constance, and I want to present our draft Dnssd privacy extensions. So the draft is about the privacy problems arising when using Dnssd, and it also gives a first solution, which we call a two-stage solution, and it was added in the second version of the draft. First, I want to talk about the privacy problem. So let's assume that Alice enters a network and she wants to offer a presence. Oh, over there. That?
Ted, oh, I mean, Fred.
Was it my fault?
Ted? No, Fred.
Sorry.
Ralph. Very nice pictures, Ralph.
A dead tree in our backyard. There.
Okay. So let's assume Alice wants to offer a presence service, which is, for instance, used by iChat or Pigeon. And during service browsing, her device will offer a pointer resource record, which looks like this. And this tells other devices that there is a new service of the type presence. But this brings the privacy problem of giving a list of service instances that is offered by a device. Then for service browsing, her device will offer the corresponding text and service resource records. The service record might look like this. It contains the port on which the application is listening and the host name. The host name is a privacy problem, especially if it contains the user's name, which is often the default behavior, and the port often identifies a service type. Then the text resource record contains further information about the service and might contain private information, like here the full name or a chat status. And then for hostname resolution, we use the typical A resource record, which again discloses the host name. So as a mitigation technique, we propose a two-stage solution which divides the service discovery process in two stages. The first one is directory discovery, and the second is service discovery. The motivation for dividing this is that we want to offer services directly to peers that can actually use the service. So meaning that in the first stage, peers discover select peers, and in the second stage, they directly query them for service information. This could also be used for other discovery protocols. So during directory discovery, the host discover a special service that is offered by a private directory, and we call the service the PSDS service, and this is implemented as a minimal DNS server running on the host. And when, like in this example, Alice enters a network, she will first look for these paired peers for the select peers, and then in the second stage, query them directly. But to be able to do privacy-preserving service discovery, the devices need to know or need to identify authorized devices that are allowed to get the service information. And to establish the necessary relationship, we propose a device pairing. This is the only step that will need user interaction, so it has to be as convenient as possible. We propose two kinds of pairing. The first one is an intra-user pairing, which we use to pair devices of the same user. And then we have an intra-user pairing, which we use to pair devices of friends. So for the intra-user pairing, we can use methods that require little to non-user interaction. But for intra-user pairing, we need different means. We were discussing about push-button methods or transmitting a secret and public authentication keys, which can then be verified using QR codes. These QR code methods are already used for instant messaging applications like Pigeon, but we still don't know how to reduce this to practice, and also want to discuss pairing. So for secure, for private transmitting of the PSDS service instances, we need obfuscated instance names, and we generate them by using a secret exchanged during pairing and hashing this concatenated with a seed. And the seed is a timestamp, a write-in timestamp that allows us to pre-calculate these values. And we use pairwise identifiable obfuscated names and pack 10 of those, up to 10 of those names in one service instance name to make it more efficient. So let me summarize this two-stage approach. First, we have private directory discovery, which uses obfuscated host names. It uses encoded instance names, and only paired peers can identify these instances. And for actual service discovery, we use the PSDS service, and the actual service discovery is done via unicast to this PSDS service on a encrypted channel, and we want to use DNS over TLS using a Diffie-Hellman pre-shared key mode of operation for this. So then I want to conclude this short talk with two questions. First, should we adopt this draft? It proposes a two-stage approach for privacy-preserving service discovery, and the method is efficient as it reduces multicast. It reduces visual clutter because all these PSDS instances belong to a dedicated service type and can easily be hidden in the user interface, and it offers services only directly to paired devices. And the second question is, should we work on pairing? Pairing is essential for privacy-preserving service discovery, and other applications will also benefit from this. So thank you for the attention.
Okay, thank you. A very good, concise presentation. So Ted and Stuart are at the mic. We've got time for a few questions, so far away.
All right, so Ted Lemon, first of all, this is awesome. I love this. This is really great. Hadn't even occurred to me to do this. The pairing problem is actually slightly larger than you've described, because the way that users discover each other is that they get some message saying that they get some indication in the user interface that there's someone there to discover. Without that mechanism, they may not even be aware that there's a chat thing that they can use to talk to each other. So if you want to do this, I think that you need to be able to say something like, somebody new showed up on the network. You might want to look into that somehow. So this is really neat. I like this. I think this is a good idea.
So about this, what we as of yet thought of is that like when trying to use an instant messaging applications, users they know each other beforehand, and they will meet and do this pairing manually, and then they can engage in service discovery. So it's like out of the protocol right at the moment.
The problem is requiring an end user to expect something to work.
Yeah.
To expect something to be present requires them to have kind of a mental model that they may not have.
Yeah.
And oftentimes what happens, one of the reasons why these services are so cool is because people discover them spontaneously. So I think you want to somehow preserve the spontaneous discovery while not violating people's privacy.
Yes.
So that's what I'm getting at.
Yeah, thank you very much.
And the Christian Ritema, the idea there is that you do the pairing once, and yes, there is a question of what triggers the pairing.
Right.
And clearly, because I mean, okay, I know that I want to talk to you later. I know you are here. I establish a pairing. Okay. Then once you have paired, you get in the room. Now there are 50 people in this room, but only 5 of them have a pairing with you. So in the first stage, you will discover all the 50 people, but you'll do a triage by checking the value of the instance name to say, oh, only that one has a magic token that I understand. So you get, at that point, you get the addresses of the privacy server for your 5 friends. And then for those ones, you will contact them using, say, DNS or TLS, ask the regular Dnssd question to find out the IP address and the port number of the chat room that they want to use.
That's not really the question I was getting at, but I get that, and I like that solution.
But I really think this is a very good idea to automate this pairing process, because this is the only like ugly part of the protocol, because it needs user interaction. Yeah.
I think there's a way to do it. I'd love to talk with you about this.
Yes,
I don't know if I have time, but I'd love to.
Yes, we should work on these pairing services.
I am definitely saying that,
I
yes.
think, yeah, it's good to hear that. So I think one of the other concerns is the compatibility with everything else we're doing here. It sounds like it's something that can just bolt on as an optional extra if you choose to use it, which is a good thing. But we need to be clear that that's the case, that the device that chooses to use that benefits from it, and it doesn't lose out in discovering other things potentially. But well, Stuart.
This is really interesting work. Thank you. You said you're doing a PhD. When do you finish?
I think maybe in January.
Oh, cool. We should talk. Yeah. I do have one small question. I saw you use a time value to compute the obfuscated name. Does that mean the name changes over time? Okay, that's good. So it avoids being a tracking ID.
Yes.
Good, thank you.
Yes.
You realize, Stuart, working group chairs get finder fees, so. So, Dave.
Dave Taylor. On the 2 questions, I think my personal belief is the answer is yes, but the definition of we should be different. In the top case, the we refers to the Dnssd working group. And my belief is, yes, the Dnssd working group should work on Dnssd privacy, absolutely. And I think this draft is a good starting point. On the bottom one, I think the answer is yes for a different definition of we. I think the notion of pairing, Dnssd is not the only protocol with this problem that could benefit from pairing. I believe that the bottom one, the answer should be yes, but not within the scope of the Dnssd working group. Okay. I'm peering back at an agent.
Do you have any idea where that might be?
SAG, int area would be the 2 possibilities.
Confused AD. I'm actually not sure. I'm going to have to think about that one.
But I think that's a very good point, Dave, that so what belongs
I want there
where.
to be a solution to pairing, yes, and I want it to be not specific to DNSSD.
This is Ted Lemon. I believe Dave has a good point there. However, if we were to do this in int area, I just think it would die. Nothing against int area, but that's. What you're doing is you're taking it out of a room where there are a lot of people interested in the problem, and you're putting it in a room where there's nobody interested in the problem, because it's structurally somehow makes more sense.
So we could say that we would work on it and not preclude it from working in other environments, or do everything we possibly can to avoid.
Well, I mean, I think there's a case to be made that it shouldn't be done here, but if that's the correct answer, then I think that you're proposing to fork a new working group, because I don't know of a working group in the IETF that would have that collection of people who are interested. So from my perspective, as a matter of expediency and avoiding creating larger schedules for IETFs in the future, I think it might make sense for the area directors involved to ask themselves the question, would it be efficient to do it in here? Because I think there is a community of interest here.
Okay, so first question is, who's read this draft? There's a small number of hands, so it can be a small vote then. But from what you've heard, I mean, you can get a feel for what it's trying to do and how it may work. Who here would be in favor of the working group adopting this draft modulo where the pairing work is done? In favor? Against? So you're just taking your glasses off now, okay? So I think we've got moderates in favor, but from the people that have read it, it sounds like it looked like all those hands went up, which is good. Tom?
Yeah, I read the draft, and there's a lot of obfuscation in there. Not all of it is your algorithm. I think it would be good to have the problem defined better, and we adopt that draft, and then the solutions maybe separately.
Yeah, I think that's an interesting point. I mean, this draft started off stating a problem, and it's sort of in version 01, as version 00. Version 01, it's started taking the steps into solution space. So I guess there's a question for our AD there as to whether he would prefer that we adopted the bit that stated the problem and published that, and then continue the work towards a solution. Any comments there? Or do we do it all in one document?
I'm actually quite fine to do it all in one document.
Okay. So I think the comment there is then to make sure that the requirements and the problem are stated clearly in the draft as well, as I think they are already. Okay, Ralph's checking for blue sheets. Okay, so we will take that for confirmation to the list as to what people want to do with adopting the draft. Thank you very much again. So we've got about 5 minutes left. The last thing we were going to discuss was other drafts and next steps. So I don't think I can cut across to my laptop fast enough, or can I? There's basically, as I wreck the place, there's basically 3 drafts here that we've got outstanding from other places. Oh, it came up before. Hopefully it'll come up again. There we go. So there's, of all the drafts that we've covered, there are these 3 to the left. I think we've heard about hybrid proxy zero conf from Ray, and that we'll have to take that via Ray and discuss it with Marcus about where we stand with that. We've got 2 other drafts. The general Dnssd threats document is parked. We're not going to ask for adopting it. There are outstanding questions from a couple of people against that draft on the list that have not been answered. So once the authors answer those questions satisfactorily, we may be able to progress that. So do check the list for that thread and comment on it if you can. And then the last one, which I kind of probably fits in somewhat with what we were discussing about how you use things in practice. Maybe 5 meetings ago, we had a draft presented on how you might optimize the queries and where it's most effective to do query filtering, whether it's on the client, the server, or on the responses you receive back to the client. So it might be worth revisiting that. So I'll contact the author, see if he's still interested, or he or she, I don't remember, in revisiting that. I think it might be worth doing that at the next IETF meeting. And that just then leaves us with the final steps of next steps. Is there any work here that people think we should be doing that we're not? Any other brilliant ideas for what we should be doing? I think it's great in the last couple of meetings we've taken the privacy aspect on board. That's really good. Is there anything else that we're missing that we should be doing? Okay, so that's kind of encouraging. I think there is the potential to look at rechartering as we discussed at the start, but I think there are some clear actions at the moment on the hybrid proxy and on the DNS push split. I think we should finish those little pieces first before we consider rechartering. So a rechartering discussion might happen at the next IETF meeting, I would guess.
Yeah, let's see if we can get that started.
Yeah. So we'll have a list discussion before the meeting. A thumb up from the AD. So the actions I've got down here from the meeting, or the key ones anyway. The first one is that we'll get the hybrid proxy update done. We'll get the DNS push and signaling updates done. So the signaling work will be done first. It sounds like that's going to happen really quickly. Once that's sorted, you can then go and update the DNS push document, stripping out the bits that have moved to the signaling document. As Stuart said, semantically it's the same. There'll be some changes in the syntax. Third thing would be the design team, formal or informal, to look at the what we shall just call flat HomeNet problem for the time being. I think we all know what we mean. Related to that is also DNS updates and hybrid proxy coexisting in an enterprise or campus environment. So I think Ted currently has taken that all on himself. We need to get some help, whether people like Ray and Stuart and others may be willing. That would be great. So I think if Ted can kick off the discussion on the list again and call for help, that would be very welcome. Next thing was the guidance draft. I think we've had a good discussion there and got some ideas thanks to Ralph's presentation. I would point you also to, Tom mentioned it, he's got some configuration examples in a draft that he could post. There's a link to that in the chair's slide. So if you look back, in fact, here we go. So if you look at the chair's slides, there's a link there to the GitHub repository where his draft currently sits. It's just not published yet. So I think it expired. So have a look at that, or Tom can repost it somehow so we can all have a look. So that's more than configuration side rather than the high level, how you stitch things together, which is the sort of thing that Ralph was talking about. So we need to get a guidance draft kicked off somehow. So Ralph and Tom and maybe others will do that. And then the final thing we had was the privacy draft. We'll take it to the list to confirm adoption of that document, and we'll speak to the ADs about the best plan in terms of where you might define the pairing aspect of that, since we need to have some critical mass to work on it. And Ted has basically said if we take it out of here, we may not have any critical mass. So keeping it here may be the best thing, but we'll see. Okay, so I think that's it. Any final things anyone wants to say? If not, we're going to release you. Okay. Yep. Thank you much for coming. Make sure the blue sheets come back and that you've signed them. Oh, yeah, we've got them. Okay. If you've not signed them, last chance. Thank you. Hey, Don. How are you, man? All right. How are you doing? Thanks. I just broke my Juniper pen. How will I live? Very nice. Dnssd? Yeah. Very happy with the way this has broken another one. Thanks.